the part 2 of your homework videos. And so I'm going to read it, and then I'll go to a clean slide to work the problem. This one's really interesting. 3 couples have reserved seats in a row for a concert, and how many different ways can they be seated when there are no seating restrictions? I'll erase that so you can read it. So there's no seating restrictions. So let's say here you go with, there's 6 people going, and so you get to the venue and you've got a row, you've got 6 seats in the same row. And so let's say these are the people A, B, C, D, E, F. And so any of these 6 people, if you don't care how you sit, could sit down. And then 5, 4, 3, 2, 1. Because people can't repeat, they didn't have to say no repetition. Once somebody chooses to sit here, then the other 5 just file in. And that would be, I believe, 720. Now look at the B part. On the B part, it says, now what happens if each couple wants to sit together? So if each couple sits together, how many ways can this be done? And so if each couple sits together, here's our 6 seats that we've reserved. And so let's make these couples. Okay. So any of these people could grab that first seat. Any of these people could go, I'm sitting here. But say that this person sat there. Then the rest of the couple, their partner, spouse, date, friend, whatever, would sit right next to them. So only one person's going to sit next to them. And then there's 4 people left. Once one person in the couple sits down, the other person would sit next to them. And now this couple is left to climb over and sit down, 2 and then 1. And so there's far less ways if the couples want to sit together, and that would be 48. Okay, now let's go to, we're skipping every other odd, so now we're on 29. All right, on 29, it's just working with the notation. On 29, we have P, 8, 3. And so with a permutation, that's 8 factorial over 8 minus 3, which is 5 factorial, which you could type into your calculator, or 8, 7, 6, 5, 4, 3, 2, 1 cancels out, and you get 336. If we practiced another one like this one, this would be 7 factorial over 7 minus 4, 3 factorial, and then you would work that out. All right, so that was 29. 33 is next. This is a P26. It's a permutation. So you have 20 factorial over 20 minus 6, which is 14 factorial. And that should come out to 27,907,200. You could type it in, or you would have 20 times 19 times 18 times 17 times 16 times 15. That all cancels out, but you got to use your calculator either way, so you might as well use your factorial key. 37. How many ways can 5 children posing for a photograph line up in a row? So you're going to let all 5 children be in the photograph, and people can't repeat, so any of the 5 could be first in a row, and then 4, 3, 2, 1. So that was pretty easy. That was 120 ways to have 5 children posing in a photograph. So now let's see what we have here. That was number 37. So now we're going to 41, and I'll clean this up some, but I'm just looking for what 41 is. Okay, so 41. Let me see if I can copy just this picture. Good. All right. So 41 is you have a pool of 12 candidates, and you're going to elect president, vice president, secretary, and treasurer. And so order does matter, which order, because they're distinct offices. So it's a permutation of 12 things 4 at a time. So that would be 12 factorial over 12 minus 4, which is 8 factorial. So you have 12 11, 10, 9. That all cancels out. You could put that in your calculator where how I showed you today, or you could type it in like this, or you could multiply this out. It's 11,880 ways. And you'll see how important these counting principles are to probability as we go forward sooner, pretty soon. Okay, so now, sorry, get off of that. Okay, so that was 41. Next is, in our list is 45. 45 says write all permutations of these letters. I don't really care on your homework check if you do them all, but because we've done it in class in a way, but get started on it. So you could go A, B, C, D, A, B, D, C, A, B, oh, I think I've done that one. So I've exhausted that. So A, D, B, C, A, D, C, B, A, C, B, D, A, C, D, B. So write all permutations of the letters. They should have been a little clearer as to if you could repeat or not. But anyway, if you kept on writing, you would get 24 of them. You could put any in the first slot, 3, 2, 1. And let's go on to distinguishable permutations. I think I did this before the break, actually, with maybe the word Tennessee or Mississippi. A distinguishable permutation means, by the way, permutation by itself means that none repeat. So that's why they didn't say it up here. If it's a permutation, it's a 4, 3, 2, 1. All right, so on this one, we have 1, 2, 3, 4, 5, 6, 7 letters. And so it would be 7 factorial ways. But if we switch these 2 letters, we can't tell the difference. And there's 2 A's. So I divide by 2 factorial. And that's 7, 6, 5, 4, 3. The 2, 1 cancels out. What's interesting right now is we're hearing, if you can hear it, the people from New York are cheering for the health workers. If you hear whistling and clapping. So anyway, that's 2,520. So let's take another slide to talk about distinguishable permutations. If you had the word been, like I've been to the store, and I want to make all the permutations I can, nobody can tell the difference if you switch these 2 E's. Like normally there'd be 24 ways to rearrange 4 letters, but if these will be indistinguishable, there's no point in switching those. So my other options would be in B-E-N-E or B-N-E-E. I'm not going to have as many choices. I could do E-B-E-N, E-B-N-E. Hope you can hear the New Yorkers cheering. E-N-B-E, and N-B-E-E, N-E-B-E, N-E-E-B. I don't know how many, let's see, do I have so far? 1, 2, 3, 4, 5, 6, 7, 8, 9. And there should be 3 more. So I've been listening to people cheer and I haven't been concentrating on this. B-E-B-E-N-E. So let me look at all the ones with E again. E. Oh, I don't think I did E-E-B-N and E-E-N-B. So what do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing one because there should be 12 of them. N-B-E-E, N-E-B-E. I don't think I missed any of those. Maybe there's another one of these. B-E-E-N. Oh, well, anyway. You can try it on your own. Let's move on. Been a long day, but there should be another one. It's going to drive me crazy if I can't find it. But what I should have happened here is I have 4 letters, so it'd be 4 factorial. And these two repeat though, so I can't distinguish between them, so it's 2 factorial. That's 4, 3, 2, 1 cancels, and I should get 12 of them. So hopefully you found the one that I'm missing. You can tell me about it in class next week, because I've listed those before. I don't know what I'm doing wrong. Maybe I just can't count. All right, so let's look at one like, there's another one in the book on Mississippi. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters, so the way to rearrange all of these letters into different code words would be 11 factorial, except for you can't tell if you switch up all these S's over and over again. So there's 4 S's, so you say 4 factorial. There's 2 P's, so you have 2 factorial. And there's 1, 2, 3, 4 I's. And so that reduces it a lot. If you put this in your calculator, you would definitely need parentheses on the bottom to get that number. I think I even worked that one. Let me see if I wrote it down anywhere. I think it's 34,650. Okay, so now let's go back to our homework. And we are on number 51, so a combination. All right, if it's a combination, let me erase some of this, get it out of the way. All right, so if it's a combination is n factorial over r factorial and n minus r factorial. If it's a permutation, it's just this part, n factorial over n minus r factorial. But if it's a combination, it's both of them to take out the order. And so, sorry. So we have n factorial over r factorial, n minus r factorial. So this one is 4 factorial over 4 minus 1 is 3 factorial, and then pull that in, and you just get 4 when you work that out. If you were doing 5 factorial, we did this with binomial theorem, you have 5 factorial. If you were doing a combination of 5 choose 2, you would say 5 minus 2 is 3 factorial, and also include the 2 factorial. Again, like we did with the binomial theorem, and then work that out. Okay, so that was 53. We're going to 57 is another example of that. So you can do 57, and I'll give you the answer. So make sure, double check your answer, see if you got it right, write it out. It'd be 20 factorial over 5 factorial, 15 factorial, and 27 ends up being 15,505. 504, I think. 15,504. But double check that. Okay, and then 61. 61 is write all possible selections of 2 letters. Sorry. There we go. Write all possible selections of 2 letters that can be formed from the letters A, B, C, D, E, F. The order of the 2 letters is not important. And so this is like going A with B, and then A with C, A with D, A with E, A with F. It's kind of like you're making a group. Now I have a combination of A with B and A with C and so on. Now let's combine B with everybody. All possible selections of 2 letters. And so I've already put B with A. We're just trying to do a group of 2 letters, and so that's already been done. So I'm going to group B with C, B with D, B with E, and B with F. Now C has already been grouped with C and B, so I'm going to have C with D, C with E, and C with F. D has been already grouped with these 3, so I'm going to have D with E and D with F. E has been already combined with all of these, so I need E with F. And then F has been combined with everybody. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So an easier way to do this would have been a combination of 6 letters, 2 at a time. That would have led me to go 6 factorial over 6 minus 2, which is 4 factorial, and then go back to your R, 2 factorial. That gives me 6, 5, 4, 3, 2, 1 over 2, 1. Gives me 30 over 2, which is 15 ways, which is what I got.